Welcome to itdesk.tv. Now, a subscriber sent in these questions and just basically wanted us to go through the CSEC Information Technology past paper. So we looked at it and we said these are pretty simple. Let's just go through it and let's explain in a logical way why the answers actually make sense. So we have the first one here that says, state the function of each of the following hardware components. A. Control unit. Now if you think about that for a sec, even if you never knew anything about information technology, and you hear that there's a component called the control unit, and of course this must be in the central processing unit, the CPU of the computer. The first thing you're going to be thinking, control. Let's apply that logically to see what does that really mean. If you think about, for example, a police operation anywhere in the world, you always hear them talk about a control unit. If you talk about dialing 911, instructions, control unit, why is that? It's almost a place for logistics, a place where the operation is handled. It would be the same thing in information technology. So if there's a control unit here, it must be the same place where the operations and those instructions are being given out in order for various aspects of the computer or various aspects of the operations to take place. So, in a logical way, a control unit must be the aspect or the subcomponent of a computer or a CPU or a central processing unit, right, that handles the operations of the computer. Question B, which says arithmetic and logic unit, ALU. That's the acronym. Again, even if you didn't know, and I'm bringing you back to this because this forms the foundation of information technology. Logical thinking persons, if you start thinking logically, it will make sense and you'll understand the concepts, the underlying concepts, and it will make you a better information technology professional going forward, whether you do programming, database, any aspect that you choose to go into. This line or this type of thinking is what guides it. ALU, arithmetic and logic unit. So you see that word coming again, logic, arithmetic. What do you think that means? It must be the place or the subcomponent within the computer that handles what? Arithmetic, mathematical type functions, addition, subtraction, division, multiplication, things of that nature. Logic. If this happens, it should trigger this feature. If this happens, then this happens in a type of sequence and balances it out. That's the purpose of the ALU, the arithmetic and logic unit. C, read-only memory. This is what we call ROM, R-O-M. What is that? Now, the ROM, read-only memory, is required for those permanent instructions that the computer needs that does not change. So for example, there is an instruction that the computer executes when you press the power button. Now that doesn't change. That's read-only memory. When you press that button to turn the computer on, you actually need the computer to power on. That's a reason why those don't change. So those are instructions, permanent instructions that the computer uses or that the system uses, and it doesn't change. It's permanent. On the other side, random access memory. These are instructions, or these are instructions that the computer or that the CPU executes. This means that the instructions are here. For example, I want to open Microsoft Word. I send the instructions through that. It's random. I could choose to open Microsoft Excel. I could open a game. I could open a browser. Random. That's the random nature of that type of memory. I can open or choose to send whatsoever instruction I want in that space. Now, the more random access memory that I have available to me is the more instructions I can send at any one time, because simply I have more space. I have a larger area, or I have more memory that can accept more instruction randomly. And these are temporary. So this is temporary storage for the instructions that I want to send inside this computer system at any given time. That's the concept, a logical concept behind read-only memory, which is permanent, and random access memory, which is temporary.